Hi everyone, welcome to another video. Today we're looking at quadrilaterals. So let's start by looking at the general properties of all quadrilaterals. A quadrilateral has 4 sides, 4 vertices, and 4 angles. This is a parallelogram. As you can see, we have 1, 2, 3, 4 sides. A rectangle, 1, 2, 3, 4 sides. Rhombus, we have 1, 2, 3, 4 sides, and a square. And as you can see also, we have each one of them has 1, 2, 3, 4 angles. 1, 2, 3, 4 angles, and 1, 2, 3, 4 sides. 1, 2, 3, 4. The sum of the interior angles is always 360. If you remember the formula for polygons that we used to find the total of the interior angles of any polygon, in this case a quadrilateral which has 4 sides, the formula is n minus 2 times 180, where n is the number of sides, and we know that a quadrilateral has 4 sides. So using the formula 4 minus 2 times 180, we have 2 times 180 is 360 degrees. So any quadrilateral, the total of the interior angles of any quadrilateral, these angles, the interior angles, these ones, is always 360. A quadrilateral can be concave or convex. Most common types are convex, can be regular or irregular. What is the difference between a concave and a convex quadrilateral? A convex quadrilateral, all the interior angles, these angles, are less than 180 degrees. All the interior angles, these ones here, are always less than 180 degrees. A concave quadrilateral has one interior angle that exceeds 180 degrees, like in this case. If you notice, like this angle, for example, and this angle and this angle are all less than 180, but this one exceeds 180 degrees. Quadrilaterals can also be classified as regular or irregular. In order for a quadrilateral to be regular, all the sides should be equal, the same length, and the 4 angles should be also the same. So basically, the only regular quadrilateral is the square. All quadrilaterals have diagonals, line segments connecting opposite corners. These lines here, these dashed lines, are the diagonals. In the case of a rhombus, a square, or a kite, the diagonals cut each other perpendicularly, forming 90 degrees. Again, the only quadrilaterals where the diagonals cut each other in a 90 degree, which means that they are perpendicular, are the rhombus, the square, and the kite. Diagonal and symmetry properties. Diagonals can help determine the type of the quadrilateral. Like we said, for example, whenever we have diagonals cutting each other in 90 degrees, which means that the diagonals are perpendicular, we know that we're dealing with a square, a rhombus, or a kite. Some quadrilaterals have lines of symmetry, like squares or rectangles, while others not. Diagonal intersections can form right angles or bisect each other depending on the type. Like we said, some quadrilaterals the diagonals cut each other, forming a 90 degree, which means that the diagonals are perpendicular. Again, concave and convex. Convex, quadrilateral, all the interior angles are less than 180 degree. Concave, one of the four interior angles exceeds 180 degree. In order for a quadrilateral to be regular, all the sides and all the interior angles should be the same, which means that the only shape that is a regular polygon is the square. Here we can see different types of quadrilaterals. As you can see, all of them have four sides. 1, 2, 3, 4. 1, 2, 3, 4. Even if the diagonals don't form 90 degree, they bisect each other, meaning that when this diagonal, for example, bisect this one, it bisects, creating in the other diagonal two segments that has the same length. This diagonal, when it bisects this one, it creates two segments. This segment from this point to this point is equal to this segment from this point to this point. The same here. As we can see, a rhombus, the diagonals are perpendicular, forming 90 degree. In a square, also the diagonals are perpendicular, forming 90 degree. If a parallelogram has perpendicular diagonals, then the shape should be either a square, a rhombus, or a kite. Opposite angles are equal. This angle is equal to this angle, this angle is equal to this angle. In this case, in a rectangle, we can see, it's evident, that the four angles are 90 degree and they are all the same. As we can see in the rhombus, this angle is equal to this angle is equal to this angle. But in this case, because this is a rhombus with four sides that are exactly the same length, the four angles are also the same. In this case, we can see that the angles are also the same in a square. Let's look at a rectangle. This is a rectangle. It's a type of parallelogram. Why? Because we have this and this sides parallel to each other, and this side and this side are also parallel to each other. We call it parallelogram because it has sides that are parallel to each other. It has two pairs of sides that are parallel to each other. This is one pair, this side, and this is another pair, this side and this side. And all the angles in a rectangle are 90 degree. The diagonals are equal in length. Rhombus. All four sides are equal. 1, 2, 3, 4 are equal. Opposite angles are equal. The diagonals bisect each other at right angles. They are perpendicular, forming 90 degree. A rhomboid is another type of rhombus, only that the sides, the adjacent sides, have different lengths. It's basically a parallelogram where you have opposite sides parallel, two pair of opposite sides that are parallel. Opposite angles are equal. This angle and this angle are the same, and this angle and this angle are the same. Again, the diagonal bisect each other, creating two segments from this point to this point. This segment is equal to this segment. This segment is equal to this segment. This segment is equal to this segment. square. All the sides are the same. The four angles are the same. All sides equal. All angles 90 degree. The diagonals are equal and bisect each other at 90 degree. The diagonals cut each other forming a 90 degree. They are perpendicular. Trapezoid. They only have one pair of opposite sides. Only one pair of opposite sides are parallel. For example, this side is parallel to this side. This is an isosceles trapezoid because this side and this side have the same length and the bottom angles are the same. This is a right trapezoid forming a 90 degree at an angle of 90 degree. This is a scalene trapezoid where all the sides have different lengths. All the sides are different and all the angles are different. Kite. Two pairs of adjacent sides are equal. This side and this side have the same lengths, and this side and this side have the same lengths. Also, in a kite, as we said before, the diagonals cut each other, forming 90 degrees. The diagonals in a kite are perpendicular. So again, it's very important to know the properties of quadrilaterals because, for example, if we're looking at this shape and I see that the diagonals are perpendicular, I know that it's either a rhombus or a square. I know it's not a kite because I know the four sides are equal. They have the same length. And this helped me also know that this angle is equal to this angle, this angle is equal to this angle. So it helps a lot by knowing the properties of the quadrilaterals in order to find missing sides or missing angles. So let's start now with some exercises. Okay, so let's start with our first exercise. In our first exercise, we can see that we have a parallelogram and we have angle A, angle B, angle C, and angle D. Angle B is equal 9x minus 1. Angle D is equal 13x minus 25. And we need to find angle C. Now, remember the properties of a parallelogram. The properties of a parallelogram, they tell us that opposite angles, this angle here, and this angle are equal. This angle and this angle are equal. Opposite angles in a parallelogram are equal. Angle C is also equal to angle A. So let's start by equaling these two angles, angles D and angle B. We have that angle D is equal to angle B. So 13x minus 25 is equal to 9x minus 1. 4x is equal to 24, and we have that x is equal 6. So let's substitute x in this angle here, 9x minus 1. So angle B is equal to 9 times 6 minus 1. 9 times 6 minus 1, and this is equal to 53. This angle here is equal to 53. We know also from the properties of parallelograms that angles that are on the same side are supplementary. For example, angle C and angle B are supplementary angles, meaning that they add up to 180. Angle C plus angle B, they should be equal to 180. So angle C plus angle B that we just found, 53, is equal to 180. Angle C is equal to 180 minus 53, and this gives us that angle C is equal to 127. This angle is equal to 127. And we know that in a parallelogram, opposite angles are equal, so we know also that this angle A is equal to 127. Let's do now this one, this exercise. In this exercise, we need to find angle X, this angle here, angle X. We have angle T is equal to 65 is given. We have angle TSU is equal to 71. And we are also being given this angle SUV. And we need to find angle X. Now, one thing that we need to know that the diagonals in any quadrilateral, they create two triangles. We have this triangle here, TSU, and we have another triangle here, triangle number 2, SVU, and they have a common side, which is the diagonal of the quadrilateral. The diagonals in any quadrilateral, they create two triangles, and we know that the interior angles, of any triangle are equal to 180 degree. So if we know in this triangle the other two angles, all we need to do is add the three of them and equal them to 180 in order to find X. So X is equal to 180 minus 71 minus 65, and X is equal, let's do this using our calculator, 180 minus 71 minus 65, and we have that X is equal 44. Okay, so let's look now at this exercise. We have another parallelogram, and we have that DF is equal to 23. This line here, this segment is equal to 23. And we have that FB, this segment here, is equal to 3x minus 1. Segment DF that goes from point D to point F is equal to 23, and segment FB that goes from point F to point B is equal to 3x minus 1. And we need to find X. Again, we should always go back to the properties of parallelograms, and we know from the properties of parallelogram that the diagonals bisect each other's. the diagonals bisect each other, creating, when one diagonal bisects the other one, it creates two segments that are equal in lengths. AC, when it cuts DB, it creates two segments, DF and FB, that are equal in size. And BD, when it cuts diagonal AC, it creates two segments, segment AF and segment FC, that are equal in size. So in order to find X, we know from the properties of parallelogram that DF and FB are equal. So all we need to do is equal 23 to 3x minus 1, and then we have that 3x is equal 23 plus 1, 3x is equal 24, and x is equal 8. So this is how important it is to know the properties of all quadrilaterals, because as you can see, just by knowing that in a parallelogram the diagonals bisect each other, creating two segments of equal length, we were able to solve immediately this problem. Now, in this exercise, in this quadrilaterals, we have four angles. Two of them are being given. Actually, three of them are being given, because this one, as you can see, this is the symbol of 90 degrees, right? So we have three given angles, angle A, angle D, and angle C. And we have angle B given as 16x minus 6. And we need to find x. We need to find x. Now we know that any quadrilateral, the interior angles of any quadrilaterals are equal to 360. The sum of the interior angles of any quadrilaterals, angle A plus angle B plus angle C plus angle D, are always equal to 360. In any quadrilateral, each one of the angles added, they should add up to 360. So all we need to do is add these four angles to 360 in order to find x. So we have that 16x minus 6 plus 120 plus 60 plus 90 should be equal to how much? To 360. We have that 16x is equal to 360 plus 6 minus 120 minus 60 minus 90. So we have that 16x is equal, let's use our calculator, 16x, is equal to 96. Let's divide this by 16, and we divide this by 16, and we have that x is equal to 96 divided by 16, and x is equal to 6. Okay, so let's look now at this exercise. We have a rectangle. Let's call this let's call this side A, B, C, and D. And we need to find this side AD. Find x. We need to find AD, side AD. Now remember, a diagonal in any quadrilateral creates two triangles. In the case of a rectangle, which is this quadrilateral that we're looking at, a diagonal creates two right triangles. Two right triangles. And we have, this is A, D, and this is C. A diagonal in any quadrilateral creates two triangles. In the case of a rectangle, it creates two right triangles. A triangle with a 90-degree angle. And we have that this is 10, it's given, and we have this side is 8, and we need to find this side. Now remember, when we have a right triangle, we can apply Pythagoras, right? And Pythagoras said that the hypotenuse to the power of 2 is equal to the other two sides added, each one of them to the power of 2. We have the hypotenuse, which is 10 to the power of 2. We have another side, which is 8 to the power of 2, plus x to the power of 2, which is the unknown that we need to find. Now, doing this operation here, we have that 10 to the power of 2 minus 8 to the power of 2 is equal to x to the power of 2, right? So x to the power of 2 is equal, let's use our calculator, x to the power of 2 is equal to 36. Now, how do we get rid of the power here to the power of 2? We know that in order to get rid of the power of 2 on one side of the equality, we need to square root both sides. And this way we end up with x is equal to square root of 36, and x is equal, let's use our calculator, and we have that square root of 36 is equal to 6, which is 6 times 6, right, is equal to 36, and this is equal to 6. So here we're looking at a trapezoid, and in this trapezoid we have some information that is being given. We have that side DC is equal 10. We have that AB, the longer side of the trapezoid, is equal 18. By the way, this is an isosceles trapezoid with these two sides that are equal in lengths. We have that AB is equal 18, DC is equal 10, and we have the height also, which is equal 6. So this is equal 6. Find the measure of the angles, these angles, perimeter and area of the trapezoid. Okay, so the perimeter we know already. The perimeter is equal to 10 plus 10 plus 10 plus 18. So we know that the perimeter is equal to 48. Easy. It's all given. We know that the area of a trapezoid is equal to half the long base or the long side AB plus DC, which is the side opposite to AB, times the height, which is 6. So let's do this operation here. We have that 18 plus 10, right? 28. 28 divided by 2 times 6, and we have that the area is equal to 84. Now let's see, we know from the properties of trapezoid that the base angles, these two angles here, when we're dealing with an isosceles trapezoid, we know that the base angles are equal. And also these two angles here, angle D and angle C, are equal. And we have some very valuable information that we can use in order to start finding the angles. Let's see, for example, and I'm going to use the highlight in order to help. If we look here, for example, we have, let's highlight it green. We have here a right triangle, right? This is a right triangle. Let's draw this right triangle here. This is a right triangle. Let me change the color. Let's do it black. We have a right triangle here. And we know from this right triangle, we know that this side is 6. We know that the hypotenuse is 10. And we know how much is this side also. This side here, this side is equal to 18 minus 10, right? This side minus this side is equal to 8. And this side, this portion here of between B and where the height cuts side AB is equal also to this portion here from this point to A. And how much is this portion here? It's right, it's equal 8 over divided by 2 is 4. So we know that this side is 4. Now, when we have a right triangle, we can use trigonometric ratios, right? Remember? So, Toa. And by the way, there's a video on this channel that deals with SOHCAHTOA. But we know that when we have a right triangle, we can use SOHCAHTOA in order to find angles. And from SOHCAHTOA we know, let's continue here on this side, and we know from SOHCAHTOA, for example, that if I need to find this angle, I can use opposite over hypotenuse. I can use any one of them because actually I have all the sides, and all I need to do is find the angle. So let's use, for example, sine. Sine, I'm trying to find this angle here, theta. Sine theta is equal opposite over hypotenuse, so it's equal 6 over 10. And in order to find theta, I need to do the inverse of the sine, which is sine to the power of -1 of 6 over 10. And this will give me, and I'm going to use my calculator, of course, 36, let's use 2 decimals, 36.86. So angle theta is 36 36.86. So angle B, which is equal to angle A, is equal to 36.86. Now, we know that in any quadrilateral, the sum of all the interior angles are equal to how much? To 360, right? So we know that angle B plus angle A plus angle D plus angle C should be all equal to 360 degrees, right? Now we have angle B, and angle A, and we know that 36.86 plus 36.86 are equal to how much? 36.86 times 2. This is equal to 73.72. Let's continue here. So 360 minus 73.72, we have 286.28, right? 360 minus 73.72 is equal to 86.28. This number here is the sum of angle D and angle C. Angle D plus angle C are equal to 286.28, but we know that this angle and this angle are equal. So if we divide 286.28 divided by 2, we find that it's equal to 143.40. So angle D equal angle C equal 143.14. So we found the perimeter, which is equal to 48. We found the area, which is equal to 84. Using SOHCAHTOA, we were able to find this angle theta. We took out this right triangle here, highlighted in green. And we were able to find angle B and angle A. Each one of them is equal to how much? 36.86. This angle here is equal to 36.86, and this angle here, D, is equal to 143.14. 143.14, and this angle is also equal to 143.14, and this angle B is also equal to 36.86. Okay, so now we're looking at a quadrilateral. And what type of quadrilateral is this? This is a quadrilateral with two pairs of, two pair of parallel sides, and the internal angles are all 90 degrees. So what type of quadrilateral is this? Yes, this is a rectangle. We have two sides that are opposite and parallel, and we have these two sides are also parallel and opposite, and they have the same lengths. This side and this side, they have the same lengths, and these two sides, they have the same lengths. We also have the diagonals that intersect at this point E, and we have this horizontal line and this vertical line, both of them passing through the center where these two diagonals intersect. So this line here, FH, is cutting BC in two equal segments, HB and HC. Also on this side, AF is equal to AD. The same AB and DC, this vertical line is cutting side AB in two segments, AG, GB, that have the same lengths. The same applies to side DC, where this vertical line is cutting side DC in this point I, that creates two segments, ID equal to IC. Now, as part of the problem, we are being given side AB. Side AB equal 8, and AC, this diagonal, AC is equal 10. And we have the measure of angle ACD, this angle here, is 30 degrees. 30 degrees. Find all missing sides and angles. So let's start by finding the sides. We know that AB is 8, and we know that this point G is cutting this side, creating two segments, AG and GB, that are equal in length. So if side AB is 8, then we have that this is 4 and this is 4. I'll delete these two lines here. We have that AC is 10, and we know that the diagonals in a rectangle, they cut each other, creating four sides of equal length. So AC is equal 10, so we know that this is 5 and this is 5, right? AC is equal to DB, so we know that this segment here, DE, is equal to EB, and they are both equal to 5. And we know that this is parallel to this one, and this is a rectangle, so this side is 4 and this side is 4. Now we need to find BH, HC, AF, FD. Now, remember that the diagonals in any quadrilaterals create triangles. So let's see, for example, how we can find this side, for example, AD. We have AC and we have also DC. So let's take this triangle here, ADF. Let's see, right triangle. Here it is, right triangle, and this is A, this is D, and this is C. This is D. Okay. And this is a 90-degree angle, right? And we have AC. AC is equal to 10. And we have DC is equal 8. And we need to find this side, AD. So when we have a right triangle, we know that we can apply Pythagoras, right? And the formula for Pythagoras is the hypotenuse to the power of 2 equal to the other two sides, each one of them to the power of 2 added, right? So we have the hypotenuse is equal 10 to the power of 2 equal the other side to the power of 2 plus AD to the power of 2. So let's do this operation here, and we have that AD to the power of 2 is equal 10 to the power of 2 minus 8 to the power of 2. So AD to the power of 2 is equal 36. Now let's square root both sides, and we have that AD is equal 6. And we know that F is cutting this line, HF is cutting this side in two equal segments, this segment and this segment. So we know that AF is equal to 3, this is equal to 3, this is also equal to 3, and this is also equal to 3. Now, let's find the angles, the different angles. We know that these are 90 degree, right? And we know that this is 90 degree, 90 degree, 90 degree, and 90 degree. So if we have this angle here, 30, and this is 90, how much should this angle be? We know that any triangle, the sum of the interior angles should be equal to 180, right? So this angle should be equal to 60. This angle here also should be equal to 60. And these two angles here, this one and this one, both of them are also equal to 60. Now remember, from angle pattern, this angle is equal to this angle here. So this is 30. And this is also here 30. We know that this angle here is also 30. It's equal to this side, to this angle here. And what else do we have here that we need to find? Oh, these four angles here, right? This angle here, right? We know that this is 90 degree. And we have that this angle here should be how much? If this is 30 and this angle total is 90, this should be 60 degree. And this angle also here is 60, right? So how much, if this is 60 and this is 90 here, so this angle should be 30. The same with this angle here is 30. Also this one here is 30, and this one here is also 30. So there you go. This is how we solve this problem. Always remember that the diagonals in any quadrilateral form triangles. So in this problem, for example, we have several triangles, and we can see that we have different right triangles here that can help us by using Pythagoras find, for example, this side. We were able to find this side AD by using Pythagoras because this is a right triangle here, ADC. And by angle patterns, we know that this angle, for example, is equal to this angle because this side AB is parallel to side DC, and this line AC is cutting two parallel lines. So we know that these two angles here, this one and this one, are 30, and we know that these two angles are also the same 30. And also by knowing that the internal angles of any triangle are equal to 180, if we add all the interior angles of any triangle, they should be equal to 180. So by knowing that, we were able to find immediately some other angles. And again, by knowing angle patterns and Pythagoras, we were able to solve this problem.